So we will learn chain rule of differentiation in this section. So here's the definition of the chain rule. Suppose g is a differentiable function of x and say f is a differentiable function of g. Then the composite function f of g is differentiable at x and f prime is given by this product definition. F prime is f prime of g times g prime. You can also write if y is a function of u is a function of g, then derivative of y with respect to x is y with respect to u times u with respect to x. So I want you to observe the definition here, which is FOG of x. Say you're deriving a composite function f of g of x. So all you do is derive the outer function f. Derivative of f is f prime. F prime is a function of g, so write g of x. And then you move inside and derive the function g. Derivative of g of x is g prime x. So first you want to derive the outer function and then you want to derive the inner function. So let me write here. These two are the derivative of the outer function and the inner function. So let's do an example here. The function f of x is x to the 4 3x squared minus 2 to the 5. First, I want you to observe this exponent carefully and understand that this is a power function. So in the first step, I want you to do the outer function, which is a power function and hence the power rule of differentiation. And then I want you to move to the inner function. The inner function is an algebraic function which is x to the 4 positive 3x squared negative 2. So let's do it. Differentiation of capital F is capital F and then a prime f prime x equals, let us differentiate the outer function which is an exponent 5. So power rule says that 5, write all the functions exactly the same, x to the 4 3x squared negative 2. Now reduce the power 5 by 1, so which is 5 minus 1, which is 4. Now you move inside and then derive the inner function. The derivative of x to the 4 will be 4x cubed. Derivative of 3x squared is 6x. Derivative of negative 2 is 0, so you don't have to write it. So your answer will be 5 times x to the 4 3x squared negative 2 times 4 and then 4x cubed plus 6x squared. And again, I don't want you to do the product because it's really messy calculation. So you're good to stop at this step. The next example, cosine of a cube plus x cube, where a is a constant. You might want to recollect the derivative formula from the previous sections. Derivative of any constant function a. You're deriving with respect to x and the function a is constant here. Your answer is always 0. And you might also want to recollect the formula derivative of the cosine function in your trigonometric section. The previous section is negative sine x. One more formula which we might need is x to the n, the power rule of differentiation, which is nx to the n minus 1. So it's a combination of 3 formulas plus the chain rule for the composite function. So read this function carefully. This a cube plus x cube is your inner function and this cosine is your outer function. Let me also specify the outer inner carefully for the previous problem. Okay. So let me write dy over dx. Derivative of y is dy over dx. How did we know that we have to derive with respect to the variable x only? Why not a? So read the right hand side. Cosine of a cube plus x cube. You're already given a is a constant. So at the most you will derive the function with respect to the variable x. So with respect to the variable x, you're going to derive the function x. So derivative of the function y with respect to x, derivative of the cosine function is always negative sign. So do write negative sign. And the function inside is a cube plus x cube. So write exactly the same. So we did derive just the outer function. Now move inside and derive a cube plus b cube. Derive this inside function. Derivative of a cube is 0 because a is a constant. Derivative of x cube is 3x square. So 3x square is a smaller term. You can bring it outside 3x square when you multiply out. And then you have sine times a cube plus x cube with a negative sign. So your answer is negative 3x square sine a cube plus x cube. In the next example, you have product of two functions and you want to derive them. So write the first function is u and the second function is v. You see product of two functions, so you might want to think of the product rule of differentiation. So let me write u is 2x minus 5 to the 4 and v is 8x squared negative 5 negative 3. So let's try to find the corresponding u prime for the problem. It is 4, 2x minus 5 and then 3. So what we did was we derived the exponent 4 and we get this 4 and 3, which means we derived the outer function, the power rule. Now we move inside and derive 2x minus 5, the inner function. When we derive the inner function, we have 2x minus 5. Derivative of 2x is 2. Derivative of 5 is 0, so you don't write that. Similarly, I want you to find v prime. It is negative 3, 8x squared negative 5. The exponent changes. Negative 3, negative 1 will be negative 4. And now you move into the inner function, 8x squared minus 5. Derive it. You have 16x. So once you are done with deriving each of these functions using the chain rule of differentiation, you're good to go back, plug in the product rule. Again, let me write it here that these equality signs we did get by using chain rule of differentiation. Now here comes the product of two functions, hence the product rule. Let's get back to the problem. Derivative of y is y prime, and then you have u v prime. Fix one function, derive the other. Fix u, derive the first u prime. So you want to plug in all the values here from u, which is 2x minus 5 to the negative 4, v prime, which is negative 3 times 8x squared negative 5 negative 4 times 16x plus v. V is the expression 8x squared negative 5 negative 3 and u prime. U prime, there is no space here, I'm writing it down. U prime is 4 times 2x minus 5 to the 3 times 2. So let me multiply them out. The first term, u v prime, you have to read carefully. All this u times v prime is one single term. And all these here, the product of two terms is your second term. So you can simplify within the term. You have negative 3 times 16. I'm going to write it as negative 48. And then have x in the numerator. Bring down all the negative exponents to the denominator. Write this as 2x minus 5 to the 4 and then write this as 8x squared minus 5 to the 4th. Then you have the plugin for u will be 2x minus 5 positive 4. So you'll not be able to get this down, but rather you want to keep the positive exponents in the numerator. So let's write this as 2x minus 5 to the positive 4. Bring just the negative exponent to the denominator. 8x squared negative 5 and negative 4 becomes positive 4. So when it's positive 4, you don't have to mention its positive sign here, but just write 4. Then in the next term, you have a multiplying factor 4 times 2, which is 8. So write 8. 2x minus 5 is a positive exponent with a 3 right on the top. Just bring the negative exponent 8x squared negative 5 to the 3 to the bottom. The next example, you have x squared plus 1 divided by x squared minus 1 to the cube. Though you see a quotient form here, this one is u and this denominator is v, you're also seeing an outer function 3. So read this 3 exponent as the outer function and read all these u divided by v, this format, as your inner function. So when you derive this in the very first step, dy over dx equal to, derive the outer function using the power rule. It's 3 times the function itself, x squared plus 1, x squared minus 1. The new exponent will be 2 times, now you want to derive the inner function. Inner function is all this, inside function. So I'm going to write explicitly, you want to do ddx of the inner function, which is x squared plus 1 divided by x squared minus 1. Now for this one, you want to do a quotient rule. So let me do this on the right hand side and then let me bring it to the problem. So the quotient rule looks like this. U is the function x squared plus 1. V is the function x squared minus 1. So do find the corresponding u prime for the problem, which is 2x, and v prime for the problem, which is still 2x. Now plug in the quotient rule. The quotient rule says if you want to derive u over v, all you have is v squared, start with v u prime minus u and a v prime. So when we plug all these here, it looks like this. This is x squared minus 1 the square, start with x squared minus 1, multiply it by u prime minus u, which is x squared plus 1, and then times v prime. V prime will be 2x. So this is all the differentiation of x squared plus 1 divided by x squared minus 1. So bring it here. So you have 3 times x squared plus 1 divided by x squared minus 1 the square times all the term in the right, which is x squared minus 1 times 2x, negative x squared plus 1 times 2x divided by x squared minus 1 the square. Next you have exponential function x cosine x, and you want to derive this. The formulas which you can recollect for the exponential function is derivative of exponential e to the x is the same e to the x. Again, we have discussed this in the section 3.1 that you can do this only if the exponent is x. You can write it as the same simple exponent x. But if it's anything else than x, like x cosine in this problem, you have to do a chain rule. So let's do derivative of y with respect to x, dy over dx. Derivative of any exponential function is the same. So write exponential x cosine. This is your outer function. But read the inner function carefully, x cosine, and you want to derive this x cosine. So the derivative of x cosine, when you want to do this expression, you see that you have the product form. When you have a product of two functions, do not forget the product rule. So let's do a typical product rule for this. And you have the first function x, derive the second function, which is negative sine x, positive, fix the second function cosine, derive the first function x, which is 1. And this is your final answer. So you might want to write a chain rule for general function e to the gx. Suppose you have a function like e to the gx. This gx can be as messy as it can be. It can be x cosine, it can be a big polynomial like x squared plus 1 times cosine, or any other messy function. So derivative of e to the gx will be e to the gx, but don't forget to derive this gx again. So this is called as chain rule of differentiation for exponential function. So I want you to clearly observe the difference between deriving e to the x and deriving e to the gx. E to the x is a direct formula. E to the gx, you have to do a chain rule. In the next example, you're given a curve. You're asked to find the equation of the tangent to this curve at the point 0, 1. As soon as you see a tangent line problem, in the very first step, I want you to write the tangent line equation. Y minus fa equal to f prime a times x minus a. And also read the plugin for a and f of a. A is 0, f of a is 1. So bring those values here, 0 and 1. So all you have to find is this f prime a, which is also the slope in the problem. So if you want to find the f prime a, derive the function. Y is 2 over 1 plus e to the negative x. Understand y can also be written as f of x. So let me write f prime x equal to derivative of 2 over 1 plus e to the x. The numerator is u, the denominator is v. So you might want to do a quotient rule. So let's do it. It's 1 plus e to the negative x square. Always start with the denominator 1 plus e to negative x times the derivative of the numerator. Derivative of 2 is 0. Negative, write the numerator 2. Now derive the denominator. Derivative of 1 plus e to the negative x. Derivative of 1 is 0. Derivative of e to the negative x is the same e to the negative x. But you want to derive the negative x again, so you get a negative 1. Chain rule of differentiation. So now you evaluate this expression at a. A is your value 0. So f prime 0 is 1 plus e to the 0, negative 0, times 0, negative 2 times e to the negative 0, negative 1, divided by 1 plus e to the negative 0, and then you have a square. The entire first term becomes 0 because 0 times any number is 0. Simplify the second term and you see that e to the 0 is 1, e to the negative 0 is also 1. So all these terms become 1. So when you simplify 2 times negative 1 is 2. You have 1 plus 1, which is 2 the square, 4. Simplify, you have 1 half. So the slope in the problem is 1 half. Bring that back, plug in into the equation here. So this is 1 half times x minus 0. So all you have is 1 half x, and then you have plus 1. So this is the tangent line. Next is the derivative of exponential function a to the x. I want you to observe the difference between differentiation of e to the x and a to the x. E to the x is a natural log function, natural exponential function, and the derivative of e to the x is the same e to the x. A to the x in the first step looks similar, it's a to the x, but you have to derive this a again, which is ln a. So here a is any constant. You don't have any restriction on this. But if it's e to the x, you know it's a recurring decimal, which is 2.718 and so on. This particular value of e. And here a is any constant. So example, differentiation of 2 to the x, it's 2 to the x again, but you also have to write natural log of 2. So let's do this. Differentiation of y equal to 2 sine pi x. So in the very first step, I want you to write differentiation of y, which is dy over dx. You're deriving 2 to the some function of x. So write exactly the same, 2 sine pi x. So this is your outer function derivative. Now you move on to deriving the inner function. As soon as you write 2 to the sine pi x, you also see in the previous formula on the top, you have a ln2, or like it's a to the x ln a. So do not forget to write ln2. Now you are going to derive the inner function. Inner function in the problem is sine pi x. So derivative of sine pi x. Derivative of sine function is cosine. So write that in the first step. And now, if it's sine x, the derivative would be cosine x and you're done. But here you have cosine of pi x. So you want to derive pi x again. Again a chain rule. Derivative of pi x is pi. So it's a product of 4 functions here. And we'll end this section here.